Hello viewers, in today's class we are going to discuss one important and conceptual problem from application of derivatives, right? And here the problem which we are going to solve is from increasing and decreasing functions, right? So what we are given here, we are given a function f of x, right? So f of x is equal to cot inverse of x plus x minus log of 1 plus x square, and we have to find the intervals in which this function is increasing and decreasing, right? So in order to solve this problem, we have to make use of many concepts, and let us see. Now viewers, whenever we are given a problem in increasing and decreasing functions, what we usually do, we first differentiate the function, right? So here we are given the function f of x is equal to cot inverse x minus plus x minus log of 1 plus x square, right? So first we will differentiate both sides. It means we have to find the derivative of this function f of x, right? So f prime of x is equal to the derivative of cot inverse x is minus 1 over 1 plus x square. Derivative of x is 1. Derivative of log 1 plus x square is 1 over 1 plus x square, and then by chain rule the derivative of 1 plus x square is 2x. And now we can simplify this expression, and we can take 1 plus x square in the denominator. We have minus 1, then we have 1 plus x square, and then we have minus 2x, right? So now here minus 1 and 1 get cancelled, and we are left with x square minus 2x divided by 1 plus x square, right? So now the derivative is equal to x square minus 2x over 1 plus x square, right? So now from here we have to find the intervals in which this function is increasing and decreasing, right? So what we will do, we have to first find the stationary points, right? So we'll find the stationary points, and the stationary points of a function are the points where the derivative is equal to 0, right? So stationary points of a function are the points or the values of x at which the derivative is 0, right? So what we will do, we'll equate this expression equal to 0. So we have x square minus 2x over 1 plus x square is equal to 0, and here we have x square minus 2x is equal to 0, because 1 plus x square is obviously not equal to 0, right? So from here we get x minus 2 is equal to 0. So we have x is equal to 0 and 2, right? So the two stationary points of this function are x is equal to 0 and 2, right? Okay, so once we have obtained the values of stationary points, we'll apply the definition of increasing and decreasing functions, right? So we know that a function is said to be increasing whenever its derivative is greater than 0, right? So f prime of x is greater than 0 for all x belonging to the domain of the function, right? And the function is said to be decreasing when the derivative is less than 0, right? So here to find out the intervals in which this function is increasing or decreasing, we'll have to make use of these two definitions, right? So the slope of the tangent must be greater than 0 for increasing function, and the slope of the tangent must be less than 0 for decreasing function, right? So now let us first take the case of increasing function, right? So for increasing function, as we have just said, that the derivative must be greater than 0, right? So it means this expression, that is x square minus 2x over 1 plus x square, must be greater than 0, right? So in order to have the increasing function, this expression must be greater than 0 for all x belonging to the domain of this function f of x, right? So now here when we see this inequality, what we see in the denominator, we have x minus 2, right? And in the numerator we have x minus 2, and in the denominator we have 1 plus x square, right? So we see that 1 plus x square is always greater than 0, right, for all x belonging to the domain of the function, right? Because x square is always positive, and here we have positive 1. So this quantity is always greater than 0. So it means for this inequality to be true, this expression which is in the numerator, it must be greater than 0, right? So now we have this inequality, and we have to solve this inequality, right? So x times x minus 2 must be greater than 0, which can also be written as x minus 0 and x minus 2 greater than 0, right? Okay, so now here we have to find the intervals in which this inequality holds, right? And for to obtain the intervals, what we will do, we'll use the method of intervals, right? So method of intervals. Okay, so now here we'll draw a real number line, and here we have minus infinity, and here we have plus infinity, right? And we have just seen that the stationary points are x is equal to 0, which is here, and x is equal to 2, which is over here, right? So the stationary points will be plotted or will be represented on this real number line, right? So here we have 0, and here we have 2, right? Now viewers, here we must note that when we have two stationary points, right? See, here we have 0 and 2 are the stationary points. So when we have two stationary points, then this real number line is divided into 3 intervals, right? So the first interval is from 2 to infinity, the second one is from 0 to 2, and the third one is from minus infinity to 0, right? So we have two stationary points, so the real number line is divided into 2 plus 1, that is 3 intervals, right? Okay, and here let us first quickly revise the method of intervals, because we can directly write the intervals here, but just for the sake of new learners, we can quickly revise this method of intervals. Now see, whenever we have an expression like this, k times x minus alpha times x minus beta is greater than 0, right? See, here we have this interval, and see, this interval is of this type, that is x minus 0, and here we have x minus 2, and this is greater than 0. And for k is some real number, so for k we have 1, right? So here we are revising the method of intervals, so we are dealing the general method, right? So when we have any expression, right, any quadratic expression which is of this form, k times x minus alpha, x minus beta, and this expression is similar to this one, right? So k is 1, and for alpha we have 0, and for beta we have 2, right? So whenever we have this type of inequality, then what we do, we take the real number line, that is from minus infinity to plus infinity, and we plot these two stationary points on this real number line, right? And provided that alpha is less than beta, right? So in this case we have alpha is 0, beta is 2, and k is 1, right? Okay, so now here we see that we have positive value of k, right? So when we have positive value of k and we have the expression in the form k times x minus alpha, x minus beta greater than 0 and alpha is less than beta, then what we do, we plot the points alpha and beta on the real number line, right? And in order to split or in order to represent this real numbers line into increasing intervals and decreasing intervals, what we do, we start from this interval, that is from this interval, and we take this interval as positive, right? And the second interval, that is alternatively we can take negative sign and then we can take positive sign, right? So when this is the case, then the function is increasing from minus infinity to alpha, because here we have the positive value, and here from beta to infinity, right? And the function is decreasing from alpha to beta, right? So for increasing, we have x belongs to minus infinity to alpha union beta to infinity, and for decreasing we have x belonging to alpha to beta, right? So these are the intervals in which the function is increasing and decreasing, right? Okay, so if we use this method and this method to this inequality, we see that the value of k is 1, that is, this is positive 1. Then we have x minus alpha, alpha is 0, and x minus beta, beta is 2, right? So what we will do, so this case is similar to this one. So here we'll start with positive sign, then negative sign, and then positive sign, right? So this function is increasing on this interval, right? So this function is increasing in the interval minus infinity to 0, minus infinity to 0 union 2 to infinity, right? And this function is decreasing when x belongs to 0 to 2, because here the derivative is negative, and in these two intervals the derivative is positive, right? So this is how we can solve this problem, right? But here I would like to mention one important thing, right? Suppose instead of this inequality we have k times x minus alpha and x minus beta is less than 0, right? Okay, so when we have this case, then we can write the intervals like this, right? So here alpha is less than beta, and we can draw the real number line, and we have minus infinity to plus infinity. Here we have alpha and here we have beta, right? So when we have an inequality of this sort, then what we will do, because here we have less than 0, right? In that case we have greater than 0. So when we have less than 0, what we will do, we'll split this real number line into 3 intervals, but in that case we'll start with negative sign, right? See, in this case we had started with positive sign, but in this case we'll start with negative sign, right? And alternatively negative, positive, negative, right? So here we'll have positive sign and then we have negative sign, right? So if this is the case, then the function is increasing in this interval only, right? That is x belonging to alpha comma beta, right? But the function is decreasing from x belonging to minus infinity to alpha union beta to infinity, right? So this is how the method of intervals can be utilized to find out the intervals in which a function is increasing and decreasing.